So far, we have only been making qualitative observation using our sight. One of the disadvantages of qualitative observations is that it might be subjective. What appears to be very intense red for you might appear to be something completely different for another person. That's why it is always a good idea to include numeric measurements or quantitative measurements whenever possible. To measure color intensity, we can use a colorimeter. Here is how it works. Our sample is red in color, and everything that's red in color will absorb every light in the spectrum except for red. So the machine, the colorimeter, will have a light source that shines green light at our sample. The sample, depending on how red it is going to absorb some of the green light, and then whatever passes through is going to be picked up by a detector. The detector will compare the light with the original source and see how much of it was actually absorbed. And it gives you a number called the percent absorbance. If you have 100% absorbance, it means all the green light that were sent out from the light source were absorbed by the sample. And that means the sample is really, really red. On the other hand, if you have zero absorbance, it means nothing was absorbed by your sample, and your sample does not contain any red color at all. And you can have absorbance anywhere between 0 and 100. Okay, 50% absorbance would means only half the light was absorbed. So this way, we have a quantitative way of determining how intense the color is. It's no longer subjective and no longer depends on the person, right? It's the instrument that's doing the measurement. And more importantly, we can take these data and we can plot it on a graph. So earlier we talked about the y-axis is where we will put the dependent variable. And in this case, the dependent variable, the thing that is being measured or observed, is the absorbance. And then on the x-axis, that is going to be the temperature in our beetroot experiment.